So we are going to take a look today at sequences again, or like patterns. We're going to look at the mixture problems again, and we're going to deal with solving some formulas some more, because being able to get a variable by itself is kind of important next unit, because we're going to be trying to get things into slope-intercept form so we can graph them. So, okay, again, this is homework check 10, number 5, so we're ready and ready to go. So here, we've got to determine if the sequence is arithmetic. In other words, can I add, or we found sometimes subtract, the same number each time? If I can, I need to figure out what the pattern is. If I can't, well, then I just say no, and I go on to the next one. So the way we did this before is we said, okay, we just kind of figured out from number to number, what are we adding by? So like to get from 1 to 9, what am I adding? 8, okay. So to get from 9 to 25, am I adding 8? Are we adding 8 going from 9 to 25? No, we're not. We're adding 16. As soon as I see one that's different, it's not arithmetic. I'm done, because there's not a common difference, because it's going up by a different number every time. So that's one of the things that we're gonna work at a little bit. Okay, what about number 2? Oh dear, okay, yep, gotcha. How about to get from 4 to 16? 12. Is it 12 to get from 16 to 36? No. Like, dang, Harty, why are you putting them all no? Purely by chance. I'm just saying. All right, let's see here. Ooh. 1 to get to negative 1. Yeah, that's a little different. I'll slow us down a little. How do I get from 1 to negative 1? How do I get from having a dollar to owing somebody a dollar? Yeah, it's like a negative 2. But then I look and I'm like, well, wait a minute. To get from negative 1 back to 1 then, to get from owing somebody a buck to having a buck, I'd have to be plus. And again, those are different. You're like, are any of these going to be arithmetic? Well, yeah. Let's skip one here. Let's go down to 5. How do we get from negative 40 to negative 36? How do we go from owing somebody 40 bucks to owing them 36? How far, how far? The internet world is waiting. No, it is not 12. To get from 40 to 36 is 4. Yeah, now if we were looking from the beginning to the end, you'd be right. It'd be 12. But what I notice here is each time that I go from one number to the next, I'm just adding 4. So my common difference is that I need to add 4, because yes, this one is arithmetic. I can add the same number, and it can be a negative number too. But that's what we're trying to work out here. So then, okay, in our next section, we're going to do a few of these together too. We're going to go back to our formulas that we were doing before. Well, before we do the formulas, we're going to do some mixtures. If we remember before from the mixtures, what we would do is we'd make ourselves a chart, and we'd look to see what we've got working. Well, we've got liters of fruit punch, and we have percentages that we're working with. Okay, so I'm trying to remember which order we did it in, even though it's not going to matter. So let's do liters and percent, even though I think I'm doing that backwards now that I think about it. Am I? Dang. Okay, let's do that then. All right. So let's see. What do we got for the first one here? Crystal mixed 6 liters of brand A fruit punch. Now again, do I know the percentage for brand A? No. Look again. We also know, but it's in the next sentence, brand A contains 50% fruit juice. Do I put 50 in right here? 0.5. Nicely done, because we need it to be the decimal of our percentage. Good. So then I look at the next part, and I'm like, okay, well, what do I know about this other one? And 4 liters of grape juice. Okay. So what percent of the final mixture is fruit juice? Now, let's think about this for a second. If it's just straight grape juice, what percentage of that would be fruit? 100. So how do I write 100% as a decimal? How are we gonna do that? Ooh, I think I heard it. What's that? 1. Because if I do 100 divided by 100, I get 1. Okay, I don't even need the calculator. We got this. So my percent would be, I guess I'm just going to call it 1. Or I could call it 1.00. And we talked before about how when we're doing these, we're going to multiply the first 2 numbers together and set them equal to the third. So if I do 0.50 times 6, put that over there. Let's see what we get for some of these. Okay, so we've got 3. 1 times 4 is 4. And we're looking for what percent of the final mixture is fruit juice. So here's what I'm going to do. I look and I'm like, okay, I've got 10 liters because I can always add these down. We're just adding down here. So I got 10 liters and I have a total here of 7. So like we did before, what's my one step to get L by itself? Divide by 10. So let's see here. 7 divided by 10 is 0.7. So what's that as a percent? Close. We're heading the other way.
That is right. No, it's not.
70%. You were close. You just got the decimal in there. So yeah, when we're trying to get back from the decimal to the percent, we're timesing instead of dividing by the 100. Maybe that was where we went a little off. But that's what we're doing on these. We're just setting up the box, working our way through, getting to an answer. And again, you can use the note sheet we did the other day too, because I think some of you pulled that out to figure out what our percent was going to be. Okay, so let's see. Let's try one out that changes up a little bit. Let's look at 9. What's that? I know, it does get a little bit tight, but luckily we don't have a lot of steps with these. So, all right, we've got some coffee, got some more coffee. Okay. Let's chart this up. Shh. All right. So here we've got our cost, which is in dollars. We have the number of pounds of each. And then we're going to have a total. And again, if you want to use different wording in there, you can. But the idea is still going to be the same. Cost times the number of pounds equals the total.
What's pound? Do we put L in there?
Or you can write out pounds if you want to. That's okay. So let's see here. Okay, 21 pounds of the blend. So there's going to be 21 pounds here at the end. Well, it says right there, it says blend. So I know it's going to be, that's what's going to be coming at the end. Is made by combining 14 pounds of Arabica coffee beans, which cost $13 a pound. And we're going to combine that with 7 pounds of Robusta coffee beans, which cost $4 a pound. So our job is to find the cost per pound of the mixture. Okay. Now no percentages this time, so I don't have to move any decimal points around. So let's see here. 13 times 14. 182. Thank you. 4 times 7 is 28. So I have 21 pounds equals, I believe that's going to be 210. So what's my one step to get divide? Which tells me it's going to be $10 a pound for this new mix with what we put together for it. It's just kind of getting yourself set up to see how this works. All right, I think we need to do 10 and 13. Yes. All right, 10 and 13, we should be good to go here. All right. Chart it. All right. We've got cost. We have kilograms. Then we've got a total. So let's see. How many kilograms of copper, which costs $4 a kilogram, but it says how many? Well, if I don't know how many, that's going to be X. I don't know how many. Must be added to 1 kilogram of tin that costs $10 a kilogram to make bronze. So far we've got copper, we have tin, we're going to make bronze that costs, that's going to come down here at the end. Because if I'm combining copper and tin to make bronze, I would also add together these kilograms. So 4x, 10 times 1 is 10, and then this is going to be 6 times x plus 1. So those things that are at the end, these two add up to equal this one, because the copper plus the tin equals the bronze. So I'm still using the chart, but I'm just going to have to do a little bit more work this time. So I'll go ahead and distribute that through. And again, the 6 gets multiplied times both things. And you're like, dang, Harty, why are we running out of room? So let's see. I need to get my x's together. What's one way I could do it? Okay. And if I want to get my x's together, I can do that with the 6x. That would work. So negative 2x plus 10 would equal 6. Okay.
And then you minus 10.
Nice.
And then would be negative.
I agree. One step to go.
And then you would divide
Nice.
Oh, I'm lost.
You put 2.
So 2 kilograms of copper. You got it.
Wait, what's the answer?
The X is 2, which means, and the question was how many kilograms of copper?
Here. Me neither. Divide 2.
I can't put any of those in.
And that's where we get the 2.
Oh, yeah.
Okay. One more. One more. Make sure I can get that to fit still. Okay. Lots of room down here. Wish the program would let me space this a little better.
Let's do it.
Oh.
All right. One more mixture. We got percents and we got gallons. All right. Percent,
He is 9.
gallons, shh, shh, shh. And totals. So, and again, just start at the beginning. Let's plug them in. How much of brand A fruit punch, 15%, 0.15, fruit juice, must be mixed with 2 gallons of brand B fruit punch, which is 45% fruit juice, to create a mixture that contains 21. So I go back and I'm like, oh, how much of brand A? I don't know how many gallons. So this is going to set up similar to what number 10 did. I'm going to multiply those together, because it's always multiply and then equals 0.45 times 2 is 0.90. And then again, to figure out my mixture, I'm just going to add up my gallons. And then again, I'm multiplying those together. So you'll see the similarities with the two. Because what I'm going to do now, just like we did in number 10, is I'm going to take the 0.15x and the 0.90, and I'm going to set it equal to what I got when I multiplied across at the bottom. Yeah. Oh, I'm sorry, my little garbage can there's getting in the way. Thank you. But again, I just put the chart in and then I fill in all the numbers I can find, and whatever's left, that's what I'm going to be looking for. A little bit of distributing. So I'm going to multiply that 0.21 through. And again, I'm going to be in a similar situation that I was in number 10, where my first job, since I see x's on both sides of the equals, is going to be to get those all together. So any ideas out there as to which one we want to deal with first? Which x's am I moving, or what should I do?
You would do
If I want to get my x's together first, which one do we want to move? It doesn't matter.
90.90.
X's first.
I don't know. How do I do 11?
Okay, if we're going to move the 0.21, how do I do that? Do I just say 21, I'm going to put it over here? Subtract. Okay. So that would be a negative 0.06x. Okay, and so those are gone. Now all my x's are together. That's a good thing. Now my goal becomes to get this alone. So how do we say adios to 0.90?
Minus the 0.90.
Oh.
All right. And what's that last step going to be then?
Divide.
And divide. X ends up being 8 gallons of type A or brand A. And we're good. So you can see some of them are really short, some of them maybe not quite so much.
Oh my gosh, David, that's why your arm is in bed now.
Okay? So last thing. On the equations sheet, it says solve for the variable indicated in parentheses. So here's what I'm going to do.
There's not even any input.
Yeah, like 2 out of
So like for instance, on number 1, and we'll bounce around, we'll hit some easy ones, we'll hit some hard ones. If I want to get t by itself, right now I'm multiplying. Yeah, and
P.
what's on this side with t?
IR.
IR. Oh, you said IR. Okay, I just heard the R the first time. So IR cancels, and in one step, we are done. Now, are they all going to be done in one step? No. No, no, no. But again, this is going to be about doing opposites. Now, number 2 is a little bit different. I got the parentheses here. What do we normally do when we see parentheses? Distribute. So we got to do that first. But now, I look again, my goal is to get the W part alone.
So you divide by W, or subtract by 2.
Subtract 2. How do I get this out of there?
No?
Well, you were just telling me you just about had it before. If I'm adding 2L to something, I'm going to subtract 2L. I can't just get rid of the 2 right away. I've got to take whatever's furthest away, and piece by piece, I'm going to keep working away at it until I get there. Now that this term's isolated, now I can go to get W by itself.
So add 2.
Close. Since we're multiplying W by 2, what's the opposite? Divide.
I know you think that. I know you think you're
And I'm set. And the biggest thing with equations is you just got to get used to the fact that sometimes they're going to look weird. That's just the way it is. All right, let's see here. I'm trying to find some that we're going to be panicky about. 8 would be panicky. 14 looks panicky. We're going to do 11. Okay, you might think panicky right now. 11 won't be panicky, but we'll do it. And, okay, so 3, 7, 8, 11, 14. Okay, let's do this. I want to get the x's alone.
Add 6.
Yes, whatever is not in the box has got to go away. Okay, so now we got our x term alone. Now how do I dump the 5? Divide by 5. And I'm done. X is alone. So it's just taking those pieces, and if you have to do like what I'm doing here, box in what you're trying to get alone, dump whatever's not in the box, and just keep working your way towards that. 7, same thing. First job, get the term with y alone.
You minus.
We're going to minus x. So then,
And you add C.
hang on, remember,
Or
we're
divide by B or whatever.
divide by b, right, because we're multiplying it times the y, and that's it. Most of these are going to be a step, maybe 2, but it's just about doing opposites. Now, I'll admit, this next one is tricky. Because you're like, well, I want this by itself. Okay. So let's see. You remember how we get rid of fractions?
No.
Okay? Whenever we have a fraction, we can get rid of it by multiplying by its flip, which means here I'm going to multiply by 2 on both sides, because that'll get rid of the fraction part. And we're just going to do this a piece at a time. Now, most of the time we'd say, hey, we got to distribute next. And we could. And actually, yeah, that's probably the best idea for us to do right here. We like consistency. Nothing wrong with that. So let's distribute. Because now I can start working on getting my b term by itself. Since I'm adding HC, how do I undo it? Subtract it. I'm going to have to squeeze next to it here a little bit because I'm running out of room here. Let's see. Almost there.
We divide by 8.
And then just divide by h. And again, some of these can look really, really weird when they're done. You're almost like, ooh, is that right? But it is. Because I just kept undoing everything, worked my way to b, and I finally got there. So our last couple down here. Again, my goal is to get h alone. Right now I'm multiplying it by pi r squared. So how do I undo multiply? Divide. And it's going to be one step and I'm going to be done. Because I can divide by more than one thing at a time. Excuse me, more than one thing at a time. And I'm set. Kind of like that one. Now this last one, a little more interesting again. I want to get I by itself, but it's in the denominator. It kind of stinks. I'm going to do the same thing to it that I did up here. So I'm going to basically, I can flip, and by doing that, I'm actually going to multiply by the I, which is going to move it away from here. You're like, but wait a minute, you want to solve for that. I know. But it's much easier to solve for it when it's up in the numerator. So if I say in the denominator, I'll just multiply.
We divide by r.
And just divide by r. Whew, thank you. I is divided by e divided by r. Hopefully we're not going to ER. So what I'd like you to try and do is to do some of the rest of them using these as examples. Tomorrow we're going to go into unit review mode. I think I'm going to get the candy out tomorrow. See if I can get some people to help me out with some of those.
We have that every day.
You'll help me tomorrow. Okay.